Okay, so we're in the last section of Chapter 8 in Algebra 1. It is 8.6, writing and graphing exponential decay functions. Okay, so writing and graphing all in one. Just as we had written and graphed exponential growth, we will do exponential decay now. So we're going to see the difference. Okay? Okay. You don't need to draw this. This is just a little idea right here, just a little reflection, but I'm going to put it on the smartboard so it shows up in the video. Okay? So if I just take a quick little graph, XY, if I want to show exponential growth, what does it look like? Show me with your hands. How would you draw it on here? Very good. Everybody's going like this, exponential growth. Okay? So I could just write in here exponential growth. Okay? So if you wanted to show exponential, let's back it up. Exponential growth. As the x values increase, right? The y values are doing what? Increasing, right? Exponentially. That's how we see the curve. Good. So if you were going to see exponential decay, which is what we're talking about today, show me with your hands how you would draw that. I see a couple of different things. And the one that is decay is this one. I see some of you there. Okay, so as the x values, again, are increasing, what's happening to y values now? Decreasing in an exponential way. So we see the related curve, right? That's what we're going to see, and we're going to write equations for these, and we're going to be given equations and graph them, okay? So let's start with trying to write the equation, writing a rule. So what is the model for exponential equations? It's one model. You just said it earlier. The model for exponential equations, y equals ab to the x. There it is. So exponential growth and exponential decay both are exponential functions. This is it. This is the same model. The question is, where is it different? Is it the a or is it the b? X and y are just simply a point on the line, right? They're an ordered pair. So either the a or the b is going to be doing something different to give us decay. Who thinks it's the a? Who thinks it's the b? Ooh, good. Okay, so we have most people thinking it's the b. You're right. Let's see. Can you write the function rule for this? And if you are watching this on video, pause and try to write it. Okay. Do we have a pattern in the domain, the x values? Do we? Yes. Yes. We see our normal increasing by one pattern. So let's look for the pattern in the y, the range. What is the pattern in the range, Matthew?
Times 4.
And the easiest place to see it is here, isn't it? With the whole numbers, times 4. So you might back up and test it. Is 1/2 times 4 2? And is 1/8 times 4 1/2? If you need to go scratch it out, you can scratch it out. But that is correct. So we can start with our model. And, why did I do that? And so where does this factor 4 go? 3, 2, 1 for b. B, good. So we have a 4 there. Now, in order to find the a, we simply plug in which exponent? 0, good. 0. So a equals 1/2. This is 1/2 times 4 to the x. So you have graphed many of these. What do they look like when you graph 1/2 times 4 to the x? Let's plug in, well, look at what's happening to the y values. Look here, what's happening to the y values as the x's increase? The y's are increasing or decreasing? Increasing. So if you were to go grab a graph and sketch this, as the x's increase, the y's are increasing, aren't they? So it would look like what? Exponential growth. That one is actually exponential growth. And go ahead and try this one. Okay, so is there a pattern in the domain? The domain is which variable? Come on, x, right, everyone? And so we see our normal increasing by 1, right? So what is the pattern in the range? Hank? How do I get from 1 to 1/5? You could divide by what? Okay, let's see. If I divide by 5, let's try it here. Dividing by 5 divided by 5, does that equal 1? Yes. 1 divided by 5, does that equal 1/5? Yes, but we've talked about the fact that multiplication and division are inverse operations. So if you can write it as division, you can write it as multiplication. When you're dividing by 5, it's equivalent to multiplying by, good job. So we can write this as multiplying by 1/5. Multiplying by 1/5. So Hank, where does that fall in our equation?
That would be the
Good, so we have 1/5. Keep in mind, you've got to put it in parentheses so that the entire thing is the base, right? And now we need to find the A. So when we plug in 0 in our exponent here, when we plug in 0 for x, that causes the 1/5 to become 1. So our A value is 1. So do we need to write it? It's the invisible coefficient. It can just be written as this. Now, look at this. As our x values are increasing, our y values are decreasing. So you are right. It's the b that's different. And how is this b value different than what you've been working with? It's a fraction. And it's what I call a proper fraction. Why do I call it that? Okay?
Because an improper one is like when a bigger number is on top of the other.
Good. An improper is like a mixed number, right? Where you have 6 over 5. That equals something over 1. These numbers, these proper fractions are numbers between what two values? 0 and 1, right? They're 1/2, 1/4, 1/16, 1,000, or whatever. There's some number, some fraction between 0 and 1. Okay? So when you have that, you have exponential decay. Are there any questions? Okay, so now we are going to graph and compare two exponential decay, or is that what we're calling it? Yeah, functions. So you can see that we have y equals 0.4 to the x. Is that a value between 0 and 1, 0.4? How do we say that number, Haley? 0.4. Equals what? For what? For what's? What's the place value? 4/10. Good. So this is a fraction, 4/10, which equals how many fifths? 2/5. Do we all understand that's not 1 whole, right? That's a fraction. So it will show us decay. And then we're going to compare it to this one, where we have y equals 5 times 4/10 to the x. Okay? Okay, so let's start with the first equation, y equals the 0.4 to the x. And so what must we do? Table. We've got to find points. And the values, Vivian, that we would put in.
For x, -2, -1, 0, and 2.
Good. Okay, so this easiest place to start is plugging in 0. When we plug in 0, y is? Good. When we plug in 1, y is? 0.4. When we plug in 2, y is 0.4 times 0.4, which is? Good job, 0.16. And then fill in the other two. Okay, so when we plug in -1, I want to expand it a little bit in case people are struggling with that. 0.4 to the -1 is really what? 1 over, good job, 1 over, it's about location, right? 1 over 0.4 to the first. Now, when you have a decimal in your fraction, what could you do? Blow it up, good. So we blow it up by multiplying top and bottom by 10. And then the question is 10 divided by 4 is what? Good, 2.5. Now we do the same thing with the -2. Okay, but this time we have 1 over what? I hear you saying 0.16. Good, because it's 0.4 times 0.4 in the denominator though, right? So if we're going to blow this up, we're going to move the decimal how many places? Good, 1, 2, 1, 2. We have 100 over 16. So does anyone know what that is? 16 goes into 100, 6.25, something of it. Okay, good. So there's the base, the first equation, and you could go graph it before we even do the second. So go ahead and do that. Walk 0, fly 1. Walk 1, fly 0.4. Walk 2, fly 0.16. Are we ever going to hit 0? No. The number will just get smaller and smaller. The fraction smaller and smaller towards 0. It approaches 0. When we plug in -1, we have 2.5. When we plug in -2, we have 1, 2, 3, 4, 5, 6.25. And carefully graph. When I was looking at a few graphs from your assignment the last 2 days, I noticed some people have some S shapes. And that should be a real big warning flag to you. We're in exponential equations. They look like curves, like a big J, I guess, or a C. You know what they look like. Please don't let them look zigzaggy. There was a math error if you got that, or maybe your scale was a little bit funny on your paper, okay? Make sure it's a smooth curve, and make sure it doesn't cross the x-axis if it never becomes a negative. Do you know what I'm saying? That would be a glaring error in a test situation. If this thing approaches 0 and I somehow let it drop off like that, no, 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 no. It would be wrong, okay? Okay, second equation. We'll do it in a different color. How about green? So this is y equals 5 times 0.4 to the x. So if we use our same values, we can make our work a little less, right? Because we've already done 0.4 to the x over here. We can just use these values that we found and multiply them by 5, right? So that will shorten the work. So let's start with 0. If 0.4 to the 0 is 1, what is 5 times 1? 5. So you can see 5 times 1 over here would be 5. So we just multiply each of these by 5. 0.4 times 5. 4 times 5 is 20, so we would put 1 decimal place in that. And it is, good, 2. What would 5 times 0.16 be? Do you know? 5 times 16? Good, 80. So we would have 2 decimal places now, and it would be 0.8. Good. Coming up now to -1. What would 5 times 2.5 be? Good, 12.5. And then 5 times 6.25. Okay, you got some good math going, even without a calculator. Good job. Okay, so as the x values increase, are we seeing the y values decrease? Yes, we are. Good. This is decay. It should be decay. It should be decreasing. So go ahead and graph. At 0, we now have 5. 1, 2, 3, 4, 5. At 1, we have 2. At 2, we have 0.8. At -1, we have 12.5. That goes off of my graph. At -2, it goes so far off of my graph that I can't show it. So I'm just going to not show that one. Okay. So we go. Is this one also approaching 0?
Yes.
Yes, it is. It just happens to be a little bit higher right now than the other one with the points we have found. But how would you compare the green one now? What is the difference between the green and the blue?
The green is a blue strap.
This is a vertical stretch.